So welcome to the second part of the second lecture. So as we had planned that we will now discuss what is the projection of a given vector onto another vector. Okay. So far, just briefly recall that what do we know? We know that if I have two vectors and the angle between them is theta, then cosine of theta I can express in terms of u dot b, correct? And then also we saw that a given vector can be expressed in terms of its cosine of the direction angles, isn't it? So all that information will be useful at some point or the other, and then this idea of projection is basically just the further development in the same direction. Okay, so let us start. So we take a vector u, which is nothing but this vector in this picture, p to q, and then another vector is v over here. Okay, so which is this vector. Okay, and the angle is from b to u, and we are denoting it as theta. Okay, so what you do is you look at the terminal point of u and drop a perpendicular onto the vector v, and suppose that it meets the vector v on the point s. Okay, so you see that here the line is like this is the dark, and then this is slightly so what I have done is the vector v I have extended, okay, so that the perpendicular meets the vector which is the same as in the direction as given by v. Okay, so we are assuming that this is meeting at the point s. So this angle over here is a right angle. Okay, so what I have here, I have a right triangle over here, and this is u, this is b, and this vector which we see here, which is written as w1, this is called the projection. Okay, so basically what we have done, we have projected this vector onto the another given vector b. Okay, so now our job is to basically find out, okay, that what is this w1. So this w1, so we should be able to find it out in terms of u, in terms of b, and possibly in terms of the angle. Okay, so that is what we see. So when we say that we need to find out a vector, what do we mean by that? Okay, or what do we need to do? We need to understand what is the direction, and also we need to understand the magnitude or the length. Okay, now direction is clear that it is having the same direction as the vector b. Okay, so now we need to see that what is the magnitude of this. Okay, but again, this is kind of easy, so you can use your knowledge of trigonometry or coordinate geometry. If this is u and this is the right angle, then what is this? This is nothing but, okay, I should say this is mod u. This is just mod u of cosine theta, mod u and cosine theta, isn't it? And this is going to be mod u sine theta. So we know what is the magnitude. Okay, and the other picture here is basically the situation when the angle is more than pi by 2. Okay, so basically we will be doing same. Now we will be dropping the perpendicular from here. Okay, so that you kind of complete. So as I said, now we know what is the magnitude of this is nothing but mod u cosine theta, and the direction is the same as the direction of b. So I know basically projection. Okay, so what do we get? We get the projection of u onto b. Okay, so this notation also is very important, that here the vector is u and is being projected on b. Okay, the vector in suffix is denoting the vector over which we are projecting. Okay, so what is it? This is the magnitude, and direction is b. So I mean, when I say direction of b, we look at the direction of the unit vector of in the direction of b. Okay, so this is nothing but b over modulus of b. All right, so as I said, when theta is acute. Okay, when theta is obtuse, you look at the other picture. All right, so in order to understand a vector, we needed to understand the magnitude and the direction, and we have it. So we know what is the projection of u. So once I have u and b, I can completely express in terms of u, b, and then the angle between them. But from our previous discussion, you know that cosine of theta, because theta is the angle between u and b, can be expressed in terms of the dot product. So basically what we do is we substitute that over here, okay, in the third property. So I have substituted this quantity for cosine of theta, so I get this thing resulting. Okay, so projection of u onto b is u dot b, and you have in the denominator mod b square. So this is the scalar quantity, and the v is the vector. Okay, so its direction is basically determined by the direction of b, and this is going to be the scalar. Okay, all right. So the magnitude here also gets a name. It's called the scalar component. Okay, in some books you will also see they call it scalar projection of u onto v. Okay, so this you keep in mind. Okay, so now we understand how to find the projection of u onto another vector v. What you need to do is just look at the dot product and then the modulus of a vector, and in the direction of this vector v. Okay, so you see that the dot product is basically, it relates with the projection of one vector onto the another one. All right. Okay, and also if you just look at the picture again, this is my u and this is my projection of u onto b. So by the triangle law of addition of vectors, this you know what it is. This is nothing but u minus projection. Okay, so what you have actually got over here, that the vector you started with, that u, you could now write it as u minus projection and then projection. Okay, but you know this is trivial. I can always do this because this is like subtracting and then adding. Okay, but this is not subtracting and adding anything, you know, arbitrary. So these vectors, this is the projection. So the projection is in the direction of b, and the other part is basically orthogonal to b. So basically with respect to the vector b, I have decomposed u into a vector which is orthogonal to b and vector which is parallel to b. Okay, so this is very important. Okay, so the b is being basically taken as a reference over here, and then you are decomposing a vector with this reference. Okay, so this decomposition is kind of very important geometrically. Okay, so what we need to understand here, that how to derive the formula for projection of u onto b. All we need to do is this, and if we have a question like this, okay, so just take some vectors. So here I have taken u is 1, 2, 3, and b is 1, 0, 1. So we need to recall, if we want to find the projection of u onto b, we need to recall the formula, and the formula requires what? We need to see that what is the dot product and what is the modulus of the vector v. Okay, so once you compute these three quantities, okay, I have also computed mod u here because you know, you can switch the order, and you know what is the projection of u onto b, and if you want the other way around, the projection of b onto u, this is going to be 2/7 times u. Okay, so all we need to basically look at the dot product here. Okay, so the dot product tells us about the projection. Okay, all right. So now we move further. We prove these inequalities which we had promised to you. So triangle inequality, this is you know triangle inequality for a long time now. You start doing it in your school itself. So what we are going to do is, we are going to give this idea again in terms of the language of vectors. Okay, so triangle inequality, basically what does it refer to? You have two vectors u and v. So again draw the picture u and v, and the u plus b is basically going to be the third side of the triangle, correct? So it is telling us that the length of one side of a triangle is less than or equal to the sum of the other two sides, isn't it? So that is why it is called the triangle inequality. Okay, so now you know, there are several ways to prove this. You already know how to prove it using the coordinates and the idea of length. Okay, here what we are going to do is, we are just going to use the language of vectors. Okay, so we will compute this modulus. Okay, now we know that if I want to compute the modulus, what I should be doing, I should be actually doing the modulus square. Okay, so that I can write it in terms of dot product. Okay, so I write modulus of u plus b square in terms of the dot product of u plus b with itself. All right, so again we use the same their distribution property of the dot product, and when I do that, I am going to get u dot u. So this is going to give me mod u square, and then I'm going to get b and dot b, so I'm going to get mod b square, and then there is going to, because there is a plus sign here and a plus sign here, and twice of u dot b. Okay, now at this point, this quantity, they are the modulus, whereas here is the dot product. Okay, now recall that for this dot product you had an inequality which was the Cauchy-Schwarz inequality. It tells you that the dot product in modulus is less than or equal to this quantity, okay, that mod u and mod b. So I just apply that. So if I apply that, I start over here getting less than or equal to sign, because this is an inequality. So modulus of this u dot b is less than or equal to this, and now what is it? This is like a square plus b square plus twice of ab. So I just put it in a plus b whole square, and you see this side I had u plus b mod square, and this side now I have mod u plus mod b whole square. Okay, and this is an inequality. If I take the square root, the inequality is going to be preserved. So basically I get mod of u plus b is less than or equal to mod u plus mod b, which is what you wanted to prove. Okay, so just using this extra knowledge of dot product, very simply we can write down a neat proof of the triangle inequality, isn't it? Okay, so further, using the same idea, you can prove another geometric property, which is called the parallelogram law. Okay, so parallelogram we had when we just started defining vectors, we saw. So what you do is you take two vectors u and b. So look at this picture. This is my u. Okay, this is u, and this is b, and then you complete the parallelogram by taking the copies of u. So this is copy of u and this is copy of b. Okay, so now these two vectors, they form a parallelogram like this. Okay, now if I use the law of addition, the diagonals here are going to look like u plus b. Okay, this is u, b. Okay, so this is b and then this is u. So you should be thinking b plus u, b plus u. Okay, this is it clear? Okay, so then you look at the other diagonal. So this is going to be u minus b. So basically what I am saying is the diagonals of this parallelogram determined by u and b, they are u plus b and u minus b. Okay, so what is this law is telling you? This law is just telling you that if I take the sum of length square of the diagonals of this parallelogram, then it is nothing but the sum of the squares of the sides. Correct? Now you see that this side and this side, they have the same length, so that is by this twice. Okay, and similarly this side and this side, they have the same length, so that is by the twice. Okay, so this law says that sum of the squares of the lengths of four sides basically are this, they are written as u and then b and then u and then b, okay, is equal to the sum of the squares of the lengths of the two diagonals. Okay, so this is how you get this formula. Just okay, now how does one prove it? Again, the proof is easy. What you just need to do is you need to expand this u plus b and u minus b mod. Okay, and you know how to do it because we just did it for mod u plus b. So same thing you do for mod u minus b. Okay, yeah, I did not write the details here, but just using the same idea as we did for the triangle inequality, compute this quantity and then compute this quantity. Okay, now you see, when I compute these two quantities, I expect equality, so there is not going to be any need to apply any inequality or any formula. Just compute these two quantities and then see, you will see that the cross terms will cancel out. Only the terms which will survive will be mod u square and mod b square, and they will appear twice, so you will get this. Okay, so this is a small exercise which I am leaving. You can discuss it in your tutorial. Okay, and today I will just stop here. And also today we are kind of finishing one section from this chapter, which is about the dot product. So try to solve all the problems which are there in the book or in your assignment, And since you already had one tutorial, so I hope all of you had participated and uh, asked questions. You got all your doubts clarified. If not, please approach your tutor or me or Dr. Rahul with your queries over email, and then we will start a discussion. Okay. I mean, you should use this opportunity. If you have any doubt, any question, please do not hesitate. Okay, I will keep telling you this thing, because if you hesitate, you keep your doubts with yourself, then there's no way that you can resolve them. Okay. So any small doubt, whether it is from lecture or from tutorial sheet or from the book or from just any query, whatever it may be, so you should bring it forward, discuss it with any of us. Okay. So with this we stop today's lecture. We will meet again in the next lecture. Okay, see you.